Hi, Algebra 2 students. We're in section 8.6. We're looking at conic sections. So this section is going to be kind of a jumble of all the conic sections that we've talked about thus far. And so we need to just kind of remember some concepts from before. Parabolas are written in this form. Y is equal to, only one term is squared, the x term or the y term, where the other term is kind of in a slightly linear looking form. So you can kind of identify a parabolic equation by noticing that. Here with the circle, you notice that both terms are squared. The x, well, with the circle, ellipse, and the hyperbola, the x's and the y's are going to have a squared term. However, they have distinct ways of being able to be written where you can write it like this. Now, here's the thing. If you notice, I know this is a little weird, A and B are not going to be equal when you're dealing with an ellipse, because if A and B were equal, you would have a circle. Kind of deep. You think about it. Because really, I could like rewrite this as put r squared underneath, right? So it's kind of in like what looks like an ellipse form. So I'd have, so rewriting it in this way, it looks totally like an ellipse, right? But it's not, because in this case, r squared and r squared is the same thing, and it would be an ellipse where a and b were the same. So if you find yourself in a situation where you're writing an equation and the ellipse has a and b the same, really you've got a circle. It'll make sense, I think, when we do some more examples. And a hyperbola is its own thing. A and B can be the same. It's going to have a subtraction sign between the two terms. So that's just us kind of getting a little bit refamiliarized with some of the concepts that we've talked about before. Let's go ahead and look at this first example. We're asked to rewrite an equation of the conic section. Rewrite this equation, write it in standard form. I noticed that x squared and y are both squared. So I know for a fact that it is not a parabola. Are you with me? Because remember, in a parabola, only one of those terms will be squared, while the other one is kind of to the first power, the other one will be to the second. So since both x and y have representation to the second power, I'm going to try to rewrite this using the techniques that we've learned in the past, which is kind of like completing the square. Let me use a pen that I like. I want a thicker pen. So x squared, I'm going to move the x terms together. So I'm writing x squared minus 6x plus 4y squared, and I'm going to put the constant term over on the other side. So that's going to give me a positive 7. Take a moment to make sure that makes sense. Then we're going to complete the square of each of these terms, because we notice that each of these terms, when they're written in the formula, is kind of like perfect square trinomials, right? X minus something squared, x plus something squared, or whatever. So x squared minus 6x, I'm leaving a blank, plus 4, I'm going to factor that 4 out, y squared, and that's equal to 7. I haven't changed the values yet, but now I'm going to add different things. What's going to complete the square here? Half of this, quantity squared, which is going to give me 9. What's going to complete the square here? Well, this is a completed square, so I don't have to do anything, but I'm going to leave that 4 outside for a reason. And so here, I literally only added 9 to both sides, right? Because there's nothing multiplying this parentheses. So when I write this in a simplified form, I end up with x minus 3 quantity squared plus 4 times y squared is equal to 16. The next thing I do is I divide everything by 16, right? And the reason why I do that is because I know that this thing having a coefficient is not going to put me in a circular form, because there's never a coefficient here. So when I see that I have a coefficient that is different, so here the coefficient will be 1 and here the coefficient is 4, I know that this is, I already have the sense that this is going to be an ellipse. And so now, because my a and b values will change with a coefficient. I know that's subtle, but I hope it makes sense. So I've got x minus 3 quantity squared over 16 plus, this reduces to 1/4, y squared over 4 is equal to 1. So indeed, this is a hyperbola. Now, do they want us to graph it? Okay, not a hyperbola, sorry. It's an ellipse. So they want us to graph it. I'm going to get some space here, make this a little bit smaller, and get to graphing, just so we remember how to do it. So here's my X and Y axes. I'm going to start with the center of the ellipse, which is going to be at 3, 0. So that's going to be at 1, 2, 3, 0. So here's my center. Let's get rid of that. So there's my center. Now my major axis, this is a squared. So my major axis will be 4 points in each direction, 4 points this way and 4 points that way. So this is also horizontally oriented because of that X. So 1, 2, 3, 4, and then 1, 2, 3, 4 back here. So I've got that part. My minor axis will be, I get that from the square root of this, which is B, so that's going to be 2. And so up 2, 1, 2, down 2, 1, 2. And so this gives me the gist of the shape of my ellipse. Not really pretty, but you see where we're going. Did they ask us for any other information? State whether the graph is a parabola, blah, 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 graph the equation. I think that's it. We know how to find the location of the foci in this case, because what we would do is we would use, in this case, a squared is equal to b squared plus c squared, or written differently, b squared plus c squared is equal to a squared. So we could find that by doing 4 plus something squared is equal to 16, and then we get that c squared is equal to 12, and then we get that c is equal to plus or is equal to the square root of 12, right? And so the square root of 12 is going to be less than 4, but greater than 3. So if I definitely wanted to, and they didn't ask, so in the future I probably won't do this, but I just want us to have a decent reminder, I'd realize that our foci would be here, okay? Somewhere at, and I start with the center, so at 3 plus the square root of 3, let me write that down. At 3 plus the square root of 12, I said 3, my fault, 0, and this value would be at 3 minus the square root of 12, comma 0. All right, so I can find all of these values in that way. Let's look at the next example, shall we? Okay, well, first, before we do that, they're giving us a way to, the text is giving us a way to kind of identify different conic sections while it's in this form, while it's in this expanded, or sometimes referred to as, in this case, standard form. Okay, so my pen went a little wild there. So what we'll see is that, so let's look at the information that they gave us, and I'm going to even use our highlighter. So for A, let's use a bigger one. So for A, so a parabola is going to have either a value for A, either A equals 0 or C equals 0, but you won't have both having a numerical value. Let's see what A is. A would be the x squared term, and C is the y squared term. So what we're hearing here is that what we talked about before, only one of these terms would be squared. We would only have x squared or only have y squared. We won't have both. So either A is equal to 0, where we have a y squared, or C is equal to 0, where we have an x squared, but not both. In a circle, A and C would be equal. Let's think about A and C in this case. So in a circle, A and C would be equal. What does that mean? Now, if you remember that example we talked about just now, I said that we wouldn't have, when I factored out the 4, let's see, when I factored out this 4, that was the C term. And notice that the A term was 1. And remember I said that we have a 1 here and kind of a 4 understood, and since they're not the same, I know it's an ellipse. That's alluding to the fact that, well, that's exactly the fact that I'm thinking about. When A and C are equal, then we're going to have a circle. But if they are not equal in that situation, we're going to have an ellipse. All right? And if A and C have opposite signs, meaning we're doing some, let me see if I can find that, meaning we're doing some subtraction, right? If A and C, those lead coefficients, have opposite signs, then I know that we're going to have a hyperbola. So this is really nice to hold on to in terms of just being able to do quick identifications of the type of conic section that we'll have. All right, so with that in mind, let's go ahead and look at some of these examples. Okay, So what I'm seeing here is, and I took away the textbook answer so we can look at it ourselves. If we had, without writing the equation in standard form, without changing anything, state whether the graph of the equation is a parabola, a circle, an ellipse, or a hyperbola. Remember that the two terms that were most important for us to look at were the a term and the c term, where a was the coefficient of the x squared term and c was the coefficient of the y squared term. So I'm going to circle those two important things in each problem and see if we can kind of remember the rules that we had before. Okay, so one thing that I know is is that if a and c are equal, then we have a parabola. And here, no, we have a circle and we don't. If a and c, if one a or one c is 0, then we have a parabola, which we don't, right? So it's not a parabola and it's not a circle. Now the next question, is it an ellipse? Now the thing here is that A and C have to be not equal and have the same sign. So they are not equal, so it could be an ellipse, but they don't have the same sign. So that just leaves the hyperbola, where they have opposite signs. Do you see how we did that? Let's look at this next example. Here, A and C both exist. They're not 0. They're non-zero situations. Therefore, I know that this is not a parabola. Let me get rid of my x's so I can put some new x's down. So this is not a parabola. A and C are equal, so this can't be the case. And this can't be the case because, remember, they have to be opposite signs. You can't be equal and have opposite signs. And A and C are equal, so we know we have a circle. Circle. Okay. And the next one, we have only a C value, no A value, or our A value is 0. Therefore, I know I have a parabola. So 8.6 is a relatively short section. Please check out the assignment. Do as many problems as you possibly can, using maybe this chart as a help and this chart as well. And I look forward to talking to you soon. Bye-bye.